Now we talk about function of a random variable. So say if you're given a random variable x and its density function or mass function, then we can find expectation of a function of a random variable. So notice that random variable itself is a function. Then we can apply another function on it and we can find the expectation of that function if we are given the density or the mass function associated with this random variable x. So expectation of g of x is the summation such that all the probability associated with the random variable is greater than 0. So you have g of x times probability that x is equal to small x. So if this g of x was just the identity function, then we just get the expectation of the random variable. So for the identity function, this g of x will just become x times probability that x is equal to x, and here g of x is just this random variable x. So you get the expectation of the random variable back. So let us see this in an example which will make things more clear. So suppose that this random variable x has the mass function given to us as probability that x is 0 is 0.2, probability that x is 1 is 0.5, probability that x is minus 1 is 0.3. So say our function is g of x is x square. So x is 0, then x square will be 0 square. So you have g of x, which is x square, times probability that x is equal to small x. So probability that x is 0 plus 1 square. So g of x now is 1 square. So g of x is x square. 1 square times probability that x is equal to 1 plus now again g of x. So now we are talking about g of minus 1 times probability that x is equal to minus 1. So this is g of 1, this is g of 0. So again g of 0 times probability that x is 0 plus g of 1 times probability that x is 1 plus g of minus 1 times probability that x is minus 1. And g of x is just x square. So that's why we have squares here. Probability that x is 0 is 0.2 taken from here. X is 1 is 0.5. Probability that x is minus 1 is 0.3. So that's what we plug it in here. So 0 square is 0, 1 square is 1, minus 1 square is 1. You multiply everything. So this term will become 0. You have 0.5 plus 0.3, which gives you 0.8. We can do a similar thing for a continuous random variable x. So now we want to find expectation of g of x. So you have minus infinity to infinity g of x f of x dx. So this f of x now is the density function. So this is the density function. So let us do an example here. Say if x is uniformly distributed on the interval alpha to beta and g of x is given as x cube. So then expectation of g of x is, so you write g of x first, so this is x cube times f of x. F of x for a uniformly distributed random variable is 1 over beta minus alpha. And notice the interval is from alpha to beta precisely because for the uniformly distributed random variable we define it is non-zero only in the interval from alpha to beta. So 1 over beta minus alpha you can take outside and you can see integral of alpha to beta x cube dx is x4 by 4 alpha beta. So you have this here, beta 4 minus alpha 4 by 4. This beta minus alpha comes from here. So therefore you can find expectation of g of x. Now important note is that expectation of ax plus b is a times expectation of x plus b. Here a and b are constants. A and b are constants. So notice that it's always the case that expectation of a constant, c is a constant, is just c. So that is because you can write this as c times probability that we have a constant. Now probability of a constant is always 1 because that is the only thing which will come out. There is no probability with the constant. Constant means the outcome is the same every time. It is a constant outcome. So you can either expand it using this formula or integration, or you can simply say that there is no probability associated with the constant, and therefore this a comes out. There is no probability associated with it. Similarly, there is no impact on b. And summation sign also comes out because summation filters out through either summation sign or integral. So integral of two functions, say g1 and g2, is nothing but integral of g1 plus integral of g2. You could say the same thing with summation sign, and that is why this formula holds. This is a very important result, and it shows up multiple places, so this should be memorized.